Let's first introduce the inverse CDF method. Suppose we want to draw a random sample X from a continuous distribution. X has probability distribution density function fx, small f, and its cumulative distribution function CDF is large fx. I included footnotes over here for X to indicate that these PDF and CDFs correspond to the distribution of the random variable X. However, when you write your homework, you don't necessarily have to include the footnote. Further, let us assume that the support for X is an open interval a to b, where negative infinity is less than or equal to a is less than b, and b is less than or equal to positive infinity. You can see that here a and b can take values of negative infinity and positive infinity respectively. In other words, the probability density of x is greater than 0 for all x between a and b, and the density is equal to 0 otherwise. This ensures us that the CDF large fx is a strictly increasing function and that its inverse, f inverse x, is well defined on the interval between 0 and 1. When these assumptions are satisfied, we can obtain draws from X using the inverse CDF method. So here are the procedures for the inverse CDF method for continuous random variables. To obtain a total of n draws, x1 all the way up to xn, from this distribution, the first step is to find the inverse of the CDF. Let's denote this inverse function by h, where h of u is equal to fx inverse of u. So it's the inverse function of the CDF of x. The second step is to draw n uniform samples, u1 all the way up to un, from the uniform distribution between 0 and 1. Then the third step is the transformation step. Here, we want to transform each of the u's as follows. We set x1 equal to h of u1, x2 equals h of u2, etc., and xn equals h of un. And then we're done. So the samples x1 all the way up to xn that we obtained this way can be shown to follow the distribution fx. In other words, they have the same distribution as the original x.